This video is actually another one of those check your work kind of videos. It's Descartes' rule of signs. I'm going to do page 201, number 10. You're going to do page 201, number 9. It's a little easier. You're welcome. All right. So Descartes' rule of signs. You're going to give a function. You're going to leave it alone. And you're just going to count up how many times the signs changes from positive to negative, negative to positive. And that's going to tell you the number of possible positive real roots. Then what you're going to do is you're going to change all the x's to negative x's, simplify your work, and then see if there's any sign changes. Those will tell you the number of possible negative real roots. There's one more thing you have to do, which is take away 2 from everything until you get to 1 or 0. We'll talk about that. And then finally, whatever you get here, take that away from the total number of roots you can get from the degree of the function, and that's going to be how many possible imaginary roots you can have. So this is how you get how many possible real roots, positive real roots, negative real roots, and then take that away from the total number, and that's how many imaginary ones you have. So for number 10, step 1 is to leave it alone and count all the sign changes. All right, so here's a positive number to a negative number. 1, negative to positive. 2, positive to negative. 3, negative to positive. 4. So I have 4 possible positive real roots. Oh, and look at the total number of possible roots there is. Now, from here, though, I have to take away 2 until I get to the number 1 or 0 when I stop. So it's really 4 or 2 or 0. So there are 4 or 2 or 0 possible positive roots. Okay? Now, I have to do sign changes. And this is where you need to start becoming clever. So I have 3 times negative x to the 4th minus 7 times negative x cubed plus, now I'm going to do this for you on the video, but in class I'm not actually going to write this out the whole way, and you will see why in a second. Because anytime you raise a negative number to an even exponent, it is positive. But a negative to an odd is negative, so a negative times a negative is a positive. Negative to an even exponent, still positive. Negative times a negative, positive. Sorry, that's going to be a 13. And then we have plus 8. So I plugged in negative x for all my x's, and I did math to simplify it. So now I look to see if there's any sign changes. Let's see. Positive to a positive, nope. To a positive, nope. To a positive, nope. To a positive, nope. There are no sign changes, which means there are 0 possible negative roots. All right, now up here, if there are 4 positive roots, that's all of them, right? There's only 4. But if there are 2 positive roots and no negative roots, there could be 2 imaginary roots. If there are no positive roots and no negative roots, there could be 4 imaginary roots. Okay, so here are my answers to number 10. 4 or 2 or 0 possible positive real roots, 0 possible negative real roots, and 2 or 4, actually, and I guess I should say, or 0. I forgot to do 4 minus 0 is 0. Sorry, 4 minus 4 is 0. 2 or 4 or 0 imaginary roots. Okay, so go ahead and do number 9. And really what we use this for is just like with the rational root theorem, we're going to use this for when we're doing the synthetic division and the factoring and the grouping on polynomials to get the solutions real and or imaginary, and then to use this just to check our work. Is it possible that we have a negative? Maybe I plugged it into the calculator wrong. It might not be. Okay? All right, so do number 9, and I'll see you in class.